Hello, precious one. I welcome you once again to Kenya Mathematics Classroom. On this particular episode, we are going to look at how best we can use the CRAMER'S rule to solve system of linear equations. The CRAMER'S rule to solve system of linear equations. Now, let's look at what the CRAMER'S rule is all about. The CRAMER'S rule is all about. Now, let's assume that we are given this system of linear equation. We have a1 x, then we have b1 y equals b1, then we have a2 x plus b2 y equals b2. Now, what the CRAMER'S rule is saying is this. Now we have what we call the coefficient matrix, and the coefficient matrix is D. Now this is how the matrix D will come out of the linear system. The matrix D, the coefficient matrix D, is the coefficient of the variables in the system of linear equations. Now the variables, we have x and y. In the constant are c1, c2. Now coefficient of the x in the first equation is a1. So the first term of the matrix is a1. Coefficient of y in the first equation is b1. So we have b1. Coefficient of x in the second equation is a2. And the coefficient of y in the second equation is b2. So that is how we come about the coefficient matrix D. The coefficient matrix D. Then we also have the x matrix, and the x matrix is written as dx. Now this is how the x matrix also comes about. Now with the x matrix, what we do is the coefficient of the x, that is a1 a2, is replaced by the constant c1 c2. So instead of a1 a2 as we have here, it will rather be c1 c2, and we maintain the coefficient of the y, b1 b2. So we have b1 b2. Then we also have the y matrix, and the y matrix is given by dy, and dy will also be equal to, we maintain the coefficient of the x, that is a1 a2. So we have a1 a2, but the coefficient of the y is being replaced by the constant. So we are going to have c1 c2. Now, in solving this system of equation, that means that we are supposed to find the value of x and the value of y. Now, if you want to find the value of x, the value of x will be determinant of the x matrix divided by determinant of the coefficient matrix, and the value of y will also be determinant of the y matrix divided by determinant of the coefficient matrix. And so this is how we use the CRAMER'S rule to solve system of linear equations. I want to go over again. Now, these are the two system of equations, linear equations we are given. We have a1, that's the coefficient of the x, plus b1, coefficient of the y term, equals c1, that's the constant. Then with the second equation, we have a2, that's the coefficient of the x, plus b2, coefficient of y, then we have c2, that's the constant. So now, if you want to find the coefficient matrix, you are now going to take the constant coefficient of the x and the y. So the coefficient of the x term here is a1. That's how come we have a1 here. The coefficient of the y term is b1. That's how come we have b1 here. The coefficient of the x term in the second equation is a2. That's how come we have a2 here. And that of the y is b2. So that is how we find the coefficient matrix D. Now with the x matrix, that's the dx. This is the dx. Now the dx, what is happening is, with the dx, the coefficient of the x, that is the a1 a2, which was a1 a2 in the coefficient matrix, is replaced by the constant c1 c2. So instead of a1 a2 in the coefficient matrix, in the x matrix, it will rather be c1 c2, but the coefficient of the y is maintained, that is b1 b2. So it's maintained, as it can be seen here. That's how can we find the x matrix. And with the y matrix, that is dy. The dy, take note that with the dy, the coefficient of the x term is maintained. That is a1 a2, as can be seen in the coefficient matrix. So a1 a2. That's how come we have A1, A2. But the coefficient of the y, that is B1, B2, is also replaced by the constant C1, C2, and that's how come we have C1, C2. Now, in finding for x and y, in finding for x, the value of x will be equal to the determinant of the x matrix divided by the determinant of the coefficient matrix, and the y will be equal to determinant of y matrix divided by the determinant of the coefficient matrix. So now we are going to see how best we can use the CRAMER'S rule to solve system of equations, and let's consider these two equations. The first equation, you have 3x, the system of equations. The first one, you have 3x plus 5y equals 9. Then we have 2x minus 3y equals minus 13. Then the second system of equations, we have 6x plus 5y equals 4. Then we have 3x plus 5y equals 7. So let's see how best we can use the CRAMER'S rule to solve that system of equations. Now, the first, we have 3x plus 5y equals 9. Then we have 2x minus 3y equals minus 13. So to solve for this means find x and find your y. Don't forget that we said that x is equal to coefficient of the x matrix divided by coefficient of the determinant of the coefficient matrix. So x is equal to determinant of the x matrix divided by determinant of the coefficient matrix, and y is also given by determinant of the y matrix divided by determinant of the coefficient matrix. Now, what is the coefficient matrix? The coefficient matrix is the coefficient, the constant coefficient of the variables x and y. So we have 3, 5, 2, minus 3. So 3, 5, 2, minus 3. And now, with the x matrix, dx, the constant coefficient of the x is replaced by the constant. So the coefficient of the x term is replaced by the constant. So instead of 3, 2, as we have here, it is replaced by 9 minus 13. So we have 9 minus 13. But the coefficient of the y is maintained, 5 minus 3. So we have 5 minus 3. Now, how do we find for the dy? The dy, we maintained the coefficient of the x, that is 3, 2. That is 3, 2. But the coefficient of the y is also replaced by the constant 9 minus 13. So we have 9 minus 13. So now that we have the three matrices, we have the coefficient matrix, then we have the x matrix, and we have the y matrix. So if you want to find x will be equal to determinant of the x matrix divided by determinant of the coefficient matrix, and y will be equal to determinant of the y matrix divided by determinant of the coefficient matrix. So now let's find the determinant of the coefficient matrix, and you know how to find determinant. So the coefficient matrix is 3, 5, 2 minus 3. So you find the determinant is the first element times the fourth element minus the second element times the third element. So we have 3 times minus 3 minus 5 times 2. So we have 3 times minus 3 minus, we have 5 times 2. So the determinant of the coefficient matrix D will be equal to 3 times minus 3 is minus 9 minus 5 times 2 will give us 10. So the determinant is minus 19. So the determinant of the coefficient matrix, is equal to minus 19. Now we need to find the determinant of the x matrix and the determinant of the y matrix. So the determinant of the x matrix, don't forget that we know the x matrix to be 9, 5 minus 13, then we have minus 3. So we have 9 times minus 3, that is 9 times minus 3 minus, then we have 5 times minus 13. So we have 5 times minus 13. Okay. So we have 5 times minus 13. So now the determinant of the x matrix will be equal to 9 times minus 13 is also giving us minus 27. Then we have minus don't forget that we have 5 times minus 13. So we have minus 65 in the bracket. So the determinant of the X matrix will be equal to minus 27 plus, then we have 65. Okay, so that will be 38. So the determinant of the X matrix will be equal to 30. That's minus 27 plus 65 is equal to 38. Now let's see how best you can also find the determinant of the Y matrix. The determinant of the Y matrix, and we are with the Y we have 3, 9, 2 minus 13. So the determinant will be 3 times minus 13 minus 9 times 2. So 3 times minus 13. So we are going to have 3 times minus 13 minus 9 times 2. Then we have 9 times 2. Now coefficient of the Y matrix here will be equal to, this is minus 39. Then we have minus 18. Then the coefficient of the Y matrix here will be equal to 57. Minus 57 will be equal to minus 57. So now we know the determinant of the matrix D, that's the coefficient matrix, is minus 19. Then we know determinant of the X matrix to be 38, and we know determinant of the Y matrix to be minus 57. So we know that if you want to find X is equal to the determinant of the X matrix divided by the determinant of the coefficient matrix, and if you want to find Y is equal to the determinant of the Y matrix divided by the determinant of the coefficient matrix. So now if you want to find for X, X will be equal to the determinant of the X matrix. What did we get? We have 38. So we have 38 divided by the determinant of the coefficient matrix. We have minus 19. So we have minus 19. And here X will be equal to minus 2. So the value of X will be minus 2. Then now how do we find for X? For Y, rather. Y will also be equal to the determinant of the Y matrix divided by the determinant of the coefficient matrix. And the determinant of the Y matrix, what did we get? The determinant of the Y matrix give us minus 57. So divided by, we have divided by the determinant of the coefficient matrix. That's the determinant of the coefficient matrix, which is minus 19. So we have minus 19. And when we divide minus 57 by minus 19, we know that we are getting 3. We are getting 3 because the minus crosses out the minus, then we have 19 goes into 57 3 times. So the value of X equals minus 2 and the value of Y equals 3. So that is how we use the CRAMER'S rule to solve for system of equations. That is how we use the CRAMER'S rule to solve for system of equations. So we are done with the first question. We are done with the first question. We are done with the first question. And so now let's see how best we can solve the second question. Now we see how best we can solve the second question. And by the time we are through with the second question, you will know how to use the CRAMER'S rule to solve system of equations. System of linear equations. So the second question, the equations are, we have 6x plus 5y equals 4. Then we have 3x plus 5y equals 7. So straight away, because now I know you understand what we are talking about. So the coefficient matrix D is the coefficient of the variable 6, 5, 3, 5. So 6, 5, 3, 5. Then the X matrix will be equal to the coefficient of the X is replaced by the constant. So we have 4, 7. Then we maintain that of the Y, and that is 5, 5. Then the Y matrix will be, we maintain the coefficient of the X, that is 6, 3, but the coefficient of the Y is replaced by the constant. So we also have 4, 7. So we are only going to find the determinant of all these three. Then the answer will come out. So determinant of the coefficient matrix, you know that it is the first element times the fourth element minus the second times the third. So we have 6 times 5 minus 5 times 3. So we have 6 times 5 minus, we have 5 times 3. The determinant of the coefficient matrix will be 6 times 5 will be 30. Then we have 5 times 3 here to be 15, and the answer is 15. So the coefficient of the determinant of the coefficient matrix is 15. Now we find the determinant of the X matrix, and the X matrix is 4, 5, 7, 5. So the determinant will be 4 times 5 minus 5 times 7. So we have 4 times 5 minus 5 times 7. 4 times 5 is 20, and 5 times 7 is 35. So 20 minus 35 is also giving us minus 15. So we have minus 15. Then we find the determinant of the Y matrix. In the Y matrix, we have 6, 4, 3, 7. So the determinant will be 6 times 7 minus 4 times 3. Okay, so we have 6 times 7 minus, we have 4 times 3. And now the determinant of the Y matrix is equal to 6 times 7 will give us 42. Then we have minus 12. We have minus 12. And the determinant of the Y matrix, 42 minus 12, that will give us 30. So now we know determinant of the coefficient matrix to be 15, determinant of the X matrix to be minus 15, determinant of the Y matrix to be 30 now. So let's see how best we can solve for X and Y. Let's see how best we can solve for X and Y. Now, X is equal to coefficient of X matrix over the determinant of the X matrix divided by determinant of the coefficient matrix. So the determinant of the X matrix, we had minus 15. So we have minus 15 divided by determinant of the coefficient matrix 15. And minus 15 divided by 15 is minus 1. So X is equal to minus 1. Then Y will be equal to determinant of the Y matrix divided by determinant of the coefficient matrix. And determinant of the Y matrix, we had 30. So we have 30 divided by determinant of the coefficient matrix is 15. So 30 divided by 15, the answer is 2. So here we have X to be equal to minus 1. We have Y is equal to 2. So that is how we use the CRAMER'S rule to solve system of linear equations. That will be all for now on this episode. Thank you.